and welcome to lesson 6.3 on inverse functions. So we already know a lot about functions. We've studied how to use them, function notation, how to plug in stuff. We've studied domain and range. We've studied just last lesson how to compose functions, make composite functions, and that'll be useful in today's lesson. So today's lesson, we're going to talk about inverse functions, and the good question is, what are inverse functions? What are these things? Well, we know what inverse operations are. They're operations that kind of undo each other, right? So, like if I took anything, let's just let it be arbitrary, like x, and I added 2 to it. The inverse function for adding 2 would be subtracting 2. And so that if you simplify this, you would just get x back. These would undo each other, right? And be gone. So inverse functions or inverse operations kind of undo each other. So I have a feeling that inverse functions will kind of be opposites or kind of undo each other as well. And so let's actually give you an example of some inverse functions, and that'll teach you some notation. So let's say we have this function f of x, and we're going to go pretty simple in this. Let's say it's 2x plus 5. Now, in Math 111, you'll dive into a lot deeper or bigger functions with inverses, but we're going to go pretty simple in today's lesson. And so the inverse for this is, here's how the notation works. You call it f inverse, and what we do is we put a little superscript of -1. So f inverse of x, and that's the notation for saying this is the inverse for f, is f with a little superscript of -1. It's kind of sloppy, but I could use a fancier one there. All right, and the inverse for this thing would be x minus 5 divided by 2. Okay, and these are inverses. Function f inverse. Okay, make this a little bit neater. Now, in this lesson, I'm going to teach you two things. One thing is how to check that these are in fact inverses, and the other is how to find your own inverse. Let's start with the simple thing of how to check, because it builds most directly off last lesson. How to check that these are in fact inverses. Well, guess what? If they are inverses, they should undo each other. So if I were to build a composite function out of them, woohoo, we just did that last class, composite functions, that's nice. If I were to build a composite function out of them, I should get something interesting. Okay, so let's actually check both directions. Let's check f of f inverse of x, and let's check f inverse of f of x. We will check both directions, because remember last lesson, order of this, these shouldn't be equal, but maybe in special cases it will be. Let's see as we kind of bear this out in today's lesson. So let's see, if I rewrite this, f is the outside function and f inverse is the inside function. So let me start with writing f 2 blank plus 5, 2 blank plus 5, and then we'll throw the f inverse in the blank, x minus 5 over 2. All right, and then all we need to do is simplify. Oh man, this is some good luck, because look, I have a 2 multiplied by this fraction with the 2 on the bottom. Those will divide to 1 or cancel. And so then I have x minus 5 plus 5. But a -5 and a +5 adds to 0, and I'm left with just x. Wait a second, so everything in the functions undid itself, and all I'm left with is whatever input I plugged in. I plugged in x. I get out x. I would be willing to say that these are probably inverses since they undid each other. Well, let's check the other direction, just for some kind of discovery here. So with the f inverse, and we will check f of x as the input this time. So let's see, f inverse is blank minus 5 over 2. And we will plug in f of x, which is 2x plus 5. 2x plus 5. I almost didn't leave myself enough space in my blank here. All right, well, I don't need the parentheses up top. 2x plus 5 minus 5, all divided by 2. And so I see immediately that plus 5 minus 5, that adds to 0. So all I'm left with is 2x divided by 2. Oh, wait, what happens to the 2 divided by the 2 here? Those will reduce out or divide out to 1, leaving me with x. Wait a second. So this time, no matter what order I did it in, all I got back was x. All of the plus 5s and minus 5s and times 2s and divided by 2s, they all kind of got rid of each other, undid each other, and I got x back. And this is, in fact, how you check to see that you have an inverse, is if you'd make a composition of those functions, the two that you suspect are inverses, everything should kind of peel off all the layers, and you'll end up with whatever the input was, just x. You'll end up with just x. And the order works in both directions. And so whether you go f of f inverse or f inverse of f, you will just get x. That is how you check that you have inverse functions. So these two are, in fact, yes, inverse functions. Okay. What if I wanted to discover the inverse of a function? So let's say I give you a function, f of x. And let's just say it's 3x minus 7. And I wanted you to find the inverse. Find f inverse of x. How are we going to do it? Well, there's some simple algebra to find this or to discover this. What we're going to do, there's kind of some steps. What you're going to do is you're going to swap the function, or it might be easier to go ahead and call this y for a second. Okay? But you're going to swap x and y, or x in the function name, whatever. So let's do that. We'll go ahead and swap. So we'll call this x equals 3y minus 7. And that feels weird, but what we're trying to do, inverse functions kind of just swap their inputs and outputs. Okay? And so we're going to swap them. Now we want everything to be y equals, so we could write it back in function notation. So the second step to this, step 2, is once we swap them, we're going to solve for y. And so you can use y, or you can use f of x, and you may want to turn it into f inverse of x. And then here, this means you'd want to solve for f inverse of x, but that's kind of a lot of writing. I like to use y because it's less than writing f inverse of x. So now all I got to do is solve for y. So let me ask you, is y by itself? No, it has a 3 and a minus 7. How do I get rid of minus 7? Oh yeah, I just need to add 7 to both sides. So I have x plus 7 equals 3y. Is y by itself? No, it has this 3, so I need to divide both sides by 3. Okay, so x plus 7 divided by 3 equals y. Nice, I think I just found the inverse. So instead of calling it y, let's go ahead and give it the proper name. F inverse of x is equal to x plus 7 divided by 3. Now, could we check our work? Yes, we just showed you how to check that we do in fact have an inverse. I'm going to do it in my head. If I took this and plugged it in for x, the 3's would cancel. I'd have x plus 7 minus 7, it'd just be x. If I took this and plugged it in here, the 7's minus 7 plus 7 would be gone, then the 3's would cancel. I just have x. So yes, we just found our first inverse. And that's as simple as it is. That wasn't very hard. So I like to use the y's, but you could have done it with f of x's. But swap the spots of the inputs and outputs of the x's and y's, and then solve so that I have y equals, or f of x equals. And then whatever you have over here, whichever side of the equal sign it's on, that is your inverse function. Let's maybe do one more. One more that's a little bit of a harder function. It's one I want to talk about, but still. So these functions that I've been starting with, this is just a plain linear function, which is most of what we focus on in Math 105, are linear functions. We've stepped out and played with a few other functions, so let's do one that's a little bit different. This is not going to be, like I said, in 111 you will hit this very hard and spend a lot of time studying inverse functions and all their properties. We're just doing a little bit. So I'm going to say, okay, let's give you a function, f of x, and let's call it just x squared minus 5. And I want you to find me the inverse to this function. Find f inverse of x. Okay, so let's take this. I'm going to do my deal here where I put a y there, and I'm going to swap the x and y. So x equals y squared minus 5. And so I'm going to want to solve for y. So, of course, I see I need to add the 5. I didn't mean to use blue again so soon since last time. Let me get green. So I'm going to add 5 to both sides. So x plus 5 is just x plus 5. And that's equal to y squared. We haven't really ever dealt with anything like this. This is why I really wanted to show you this example. So this is y squared. The way to get rid of a square is to take the square root, because square and square root are actually inverse functions of each other. And so if I square root the right side, I have to square root the left side. So what I end up with over here is the square root of x plus 5. What happens to square and square root? Well, they cancel each other out, and I'm just left with y. Okay, so I've solved for y, so there is my inverse function. So f inverse of x is the square root of x plus 5. And that comes from just understanding how do you undo a square? You square root it. Okay? There's other things you'll have to study in more depth, but for this class at this moment and this time, that's just our trick. For getting rid of a square, we will square root, and we have to square root both sides. Okay? So then I'm able to discover an inverse function. And we could go about the time to check them if we wanted to. Actually, matter of fact, let's check this one together just to see. So we'll go with f of f inverse of x. And so let's see, f on the outside, so blank squared minus 5. And plugging in, we have the inverse, which is square root of x plus 5. So you have to be good at composing functions to feel comfortable with this. All right, so the square and the square root cancels each other out, and I'm just left with x plus 5 minus 5. And of course, positive 5 minus 5, I'm just left with x. Let's check the other direction. F inverse of f of x. And so if I take f inverse, it's the square root of blank plus 5. And we will plug in, what is f? X squared minus 5. The parentheses are not really needed. And so I have x squared minus 5 plus 5. Oh, okay, we see that the 5s are going to undo each other. So all I have is the square root of x squared, which the square root and the square. Now this doesn't work when there's plus and minus signs, but since I have no plus or minus signs there, the square root of a square can undo each other, and I'm just left with x. Okay, so yeah, this is in fact the inverse, so I feel good about that. Okay, but those are the only skills we're introducing, is how to find simple inverses and how to check that you have in fact an inverse. Okay, so until next time, take care.